Welcome everyone, and let me start by asking the question that we all like. Am I audible, everyone? Yeah, all good. So yeah, welcome everyone. Today we are going to lift the curtain on the one of the most scariest kinds of security flaws. It's RCs and um ACs, remote code execution and arbitrary command execution. We'll discuss how they work, but also we'll discuss why they are so dangerous and one of the kind of like they are scary. Like you can get your machines hacked by attackers, and we'll deep dive into this. I will also share what you can do to stay protected from these kind of security flaws. Then we'll also walk through some of them that I had the opportunity to fix in the REL versions. And then at the end of the session, you will know how attackers pull these stunts and how they take over systems and make use of these exploits. So yeah, sorry, I forgot. My name is Suyash, and I'm from Red Hat. And let's get started. So the session outline. Today we'll be discussing arbitrary code execution, remote code execution, some of the popular vulnerabilities that I had the experience to fix and deep dive into. Then we'll have a demo. I'll try to do a live one, and I also have a recorded one, and we'll see some statistics and some of the greatest hits that RCs were able to do, like attackers were able to pull off some serious stuff. And then there are resources on the slides to if you want to check out the blogs and the resource pages for all these exploits. And then we'll open up for question and answers. Okay, so setting the stage right. The left screen, you'll see how Hollywood thinks like the attackers or the hackers are sitting and typing furiously on their keyboards in dark rooms. But in reality, it's not true. Like people that take over systems or the attackers, they are people who know how systems work, how data is analyzed, and uh, cre- uh, how systems analyze data and make use of their databases and everything. So, in short, attackers aren't magicians or wizards. They just have good understanding of computer systems and networks. And yeah, reality exploits are technical flaws in code, and these attackers leverage these predictable weaknesses and make use of them. Okay, next thing, arbitrary code execution. So arbitrary code execution is a whole umbrella of different attack vectors, and it is kind of one of the most popular ones. Like it is not easy to come by. It is kind of a rare security flaw. But yeah, ACs, arbitrary command execution, you can run these commands over the server. But for a normal arbitrary command execution, you need to have access to that server in a physical mode. You can like when you see in the movies that the hacker goes to an office and goes inside and plugs his keyboard and then types commands. That is AC. So to give an example for people who don't have quite a good idea of these, imagine your laptop assistant, Siri, Alexa, whatever you use. Yeah, these assistants know commands like open my music, show my calendar, right? So imagine if there is a glitch and these assistants don't see what you are asking it to do. Yeah, like if I say open my music, it will open the music app and play music. But imagine if they are not sanitizing the input that the user is giving it to, and a sneaky person says, oh, delete all of my assignments, share my pictures over email to everyone. That is AC, like that is arbitrary command execution. The system that was supposed to sanitize the input did not, and it in the end, the attacker was used to execute commands that were not supposed to be even done. Yeah. Uh, all good then. We'll move to remote code execution. This is the main topic of the talk. When you say remote code execution, it's similar to arbitrary command execution, but the only difference here is that the attacker could be sitting in any part of the world, and without even being present in the server room, they could access your systems and uh, take your data, delete it, run commands, and do things that they want to. For basic example which I shared before, like the assistant. Like imagine you got a brand new TV, right? You get a remote with it. Now that remote it lets you control your TV, do things that you are supposed to do, right? Change channels, adjust the volume, and do streaming and things. But imagine if there is a magic remote with a person that is sitting in any part of the world that you don't have, that you don't know, but they do have access to your TV. They could anytime, at any time, change the channel or blast the volume, and you are sleeping. Imagine you are sleeping at 3 a.m. and they are blasting the volume at 3 a.m. So this is how RC works. The attacker could be at the attacker could be placed in any part of the world, and they could execute commands on your system, and you won't even have an idea that they did something like this. So that's essentially what RC is in the world of computers. And in simple terms, you give a magic remote to an unknown person that is allowed to run commands and on your systems. Then, yeah, now as I said, I worked on a few of these CVs that I could deep dive into and research about them. One was Python setup tools. We know Python developers and some of others also. This tool is used to install and build Python libraries, packages, and it is basically present in all of the systems. So what the issue was that the Python setup tools did not sanitize the URLs. So if you put a URL while cloning while getting the downloading the package, there's a URL that you are supposed to get it. And the Python setup tools did not do that. So if you, let's say, an attacker could make a malicious URL and post it to a library, and they could, if you pip install it, you could get malicious code on your system, and they could have access to your system. This was fixed very fast, and they did it quite well. So what's the learning here? Setup tools lets attackers sneak in malicious code, and this means if you download unknown libraries, your machine could get attacked and hacked. Moving on, Git. Git is everybody's dream. Git had a CV itself, and the flaw came from specially crafted repositories. Like if I'm an attacker, I could specially craft a repository. I would have malicious code into it. I would have created symlinks to other files, and I would clone a repository. If I put that repository into GitHub and a normal user clones it, they could I could make sure that I run my own commands. I could run I could do anything with that commands, and it is just basic cloning stuff. It's not that difficult, or this is something that we do every day. So even a Git clone could mean your system could get hacked. So yeah, if you are tricked into running Git clone on unknown repositories, unknown packages, don't do that. It is always safe to rely on verified packages. Then this is what we'll discuss in detail. This was a bug that was found in cups printing systems. So cups is a library that is used by all of major Linux distributions to manage printers, add them. They have drivers for it. If you submit printing task, it will go through the cups library, and then it is sent to the printer that is remote to the server. So if you're let's say if you have a machine and you send a printing job to a remote server which has a printer attached to it, like we have in our offices, like you just print it somewhere and your printer picks it up. But imagine if the printer that you are sending the information to is a malicious one. Like if I post a printer saying that okay, I'll explain it in detail later, but this is the CV that we'll discuss in detail. It was a very critical vulnerability. It was rated a 9.9 CVEs score on multiple domains, and it was able to make attackers take complete takeover of the systems. So yeah, how the vulnerability works. So Cups has these filters that is uses to make prints, add the printers, add printing drivers, and make schedule jobs and things like that. So what an attacker did was silently you could replace the IPP URL. IPP is a protocol that is used by printing servers. So you could replace the IPP URL with a malicious one, and the printer, the client where the Cubs library is installed, could return back information that is not supposed to do. So there is a port, UDP port 631, that was left exposed without any authentication. Like, you could just make any request to it and it won't authenticate you. It will just accept that request and perform the things that you tell it to do. Yeah. So I'll move to the demo. Okay. Oh. How do I do that? Yeah. Okay. Yeah. So here is the Cups client that I have. You have Cups running. Is it printing? Oh, it's down there. I don't know how it is. So yeah, you need Cups running, and you need, okay, why is not up? And you need, this is running slow. I don't know why it is happening. Cups. This is the Cups browser service that is used by Cups to add new printers, add drivers, and such. So this is the client where Cups is installed, and I have a few exploit files that I'll be using to exploit this CV. I did run. Okay, so there's a small script that I wrote that will send a payload to the Cubs client here on port 631, and we'll see that it created some temporary files into this system. And here, so if I get this file and do this. Oh. You have these commands that get executed on your system. So what it does is, this attacker machine sends payload to the client machine. It will connect back to the attacker machine because there is no authentication on the UDP port, and it will take on the data that is sending. Like, on the exploit file, if anyone wants to see the exploit file, I'll show it later in the end. So in the exploit file, we are creating a new printer that is having attributes similar to what they exist in normal standards, but in the end we are using commands that will be sent to the server, and if the attacker wants to, you can change the commands, I guess. So I'm just echoing I am vulnerable on that client printer. So if that file gets run, it will execute the commands. So basically that's what we are doing here. I have a few files, but it did not work on my machine. I don't know why. I tried it before. But yeah, with this you could take reverse shells, you could scan for network, you could scan for the remote, you could scan for the usernames and the users on those remote system. You could remove databases, add uh, any commands that you like to, and you could execute them over the remote connection. The problem with this, I think we'll move to the, I know it was a short demo. I have the files and everything ready, but it's quite big. Okay, yeah. Talking about why this happens. The UDP port 631 is open without authentication, and there's a filter called as CFP printer get attributes. So that filter, it's very old, and there are printers that still use it. Like there are printers from 1990s, 2000 that use that particular filter, and you could just not make it stop. Like you can't just remove it from the cups library, because if we remove that, you'll your other printers that are very old, that will become unusable, like they will become trash. So what we did to fix it, that we sanitize the input that is given from the user. We blocked the UDP port, like it was accepting all of the connections. It will now just accept the connections from your own network, from your own what do you call it, from your own uh, or from your own LAN. So it will only accept connection requests from the own LAN, and some of the few regionalization stuff. Like if you look at various languages, then you will also have to add support for different languages. So there were some additions to different languages, and they have basically we did sanitize the inputs. So I hope that was.
Still unauthenticated?
No, it's not unauthenticated. We moved it to the local LAN.
The LAN is trust. It's not authenticated.
Yeah, but you cannot do that because it will make other printers unusable. Like
So you
it.
create microsegmentation within your local area network, so that you either have internal firewalls, or you have VLANs, or virtual LANs, or you have basically secured local VLANs, so that you can segment off that part of the traffic. Different subnet of IP addresses. There's multiple ways that you
Okay.
try to minimize the impact.
I'll look into the upstream contribution that was done to see if we could do. So the question was that it is still authenticated. I'm doing for the camera. So the question was that is it still unauthenticated? Yeah. So the answer is it's not yet, but we did fix the some issues that could lead to system takeovers. The CV in all is 3 CVs that you exploit at once could give you access to the remote RCs. So if one or two of them are fixed, then it does not. Like there's a CV in cups browse, there's a CV in cups filters, and there's a CV in cups the original thing. So in Red Hat, like what my team does, we fix the one in cups browse and we fix the one in cups filters. So cups was not useful then. Okay, so this is the recorded demo. Yeah, now moving to the greatest hits of RCs. Yeah, there was a security flaw in Log4Shell, the library that is used by Java applications to log information from their system applications. So because Log4j shell Log4j shell was used in like millions of applications. The use case of this CV was widely applicable. Like attackers, it was a very easy attack. You just needed the developer to have used a string like some specific strings in the application while logging, and the system was available for takeovers. So key takeaways from the Log4j shell CV was that you should not log untrusted inputs, and it can become remote code execution. Moving on to the next one, there was a WannaCry spread in 2017. It was using the Eternal Blue exploit leaked through Windows, and it literally encrypted files like a worm. It moved to your directories. It crawled your directories, your files, and basically encrypted them. And because of this, it had a huge impact. It locked out businesses, it locked out governments, it locked out banks, hospitals from using their own files, and they had to pay ransom to make those to get access to these files. So yeah, and the important thing here that there was a fix that was sent by Windows, but a lot of people did not apply the fix. So make sure that when the vendors of your systems give you the fixes, make sure you apply them. Yeah, some statistics. There were there are a lot of attacks happening today. Like an average breach could cost any organization around about $4 million to $5 million. It There are supply chain attacks, like they disrupt supply chains from the companies that ship products. So if they grow at this stage, the current the current the current problem with this is that they are projected to grow double. Like the current amount is $46 billion this year. It is projected to be 81 billion dollars next year. So attackers are kind of making huge problems for these companies. And if you talk about real world cases, there was an attack on Marks and Spencer, the clothing brand, that cost them 300 million pounds in profit hits. And there was a company called Arub. They lost 25 million pounds to a deepfake fraud. So what do we take from this? That you need to prevent these attacks in order to make your systems running and they do not disrupt your processes. Okay, that was it. Yeah.
So I was going to say, you mentioned updates. All right, where is it? I was going to say, if you have a large company or a company that's been around for a while, you're going to have legacy systems, and you're going to have software that can't be updated, or you might have OT, operational technology, cybersecurity, where you can go and quickly and easily make system updates. So you're going to have these obstacles where you, as you mentioned before, with the printers, you might have older printers,
Yeah.
and that if you do make an updated change, you will selectively, cut out, that part. So you might have to take a look and say, okay, how can we have this functionality and then still have security, and find that balance between the two?
Yeah, I'll just repeat the question for this. So the question was that how do we balance the functionality and the security of old applications on old systems? Is that right?
Yeah.
Yeah. So like my team specifically works on it. Like I don't know, we are supposed to talk about our companies, but my team specifically, what we do is that we make sure that the companies that use these old legacy products are secured through security patches. We ship security patches for all of these packages on Linux distributions. And I think from my perspective, like what I have seen till now in my 2 years of career, it has been a short career. I know you would have more information on this, but people do discard these updates. Like it is sent for these companies for a reason. Like they just don't think that it is important to them. And there are a lot of obstacles present in, like, let's say banks. Like banks, you need to evaluate each update, like what the change was and what the update fixed, and then only they are allowed to use that specific library. So companies or institutions need to find the perfect balance over security. And if they want to upgrade to a new system, like it's a big challenge. That's why we support all older rel versions as well. But in the end, like, Linux is kind of open source. Like there's code that is available open source for everyone to exploit. Like uh, you need uh, you need to just see what the exploit is. Uh, you need to keep up with the attack vectors, and then you can just exploit them. But on the other side, I think developers should also keep checking out what people are doing, what the current security flaws are in their market, and if they are using applications or libraries that could impact those that could be impacted by those CVs, then you could fix them or implement security measures to fix that. Does that answer your question?
No, but that's,
Sorry.
I mean, it's nice in theory that you feel, okay, we just send out the patches and they will automatically get deployed. But the real life should situation is usually you'll have old software that cannot be updated. And
Yeah.
you need that to keep running your business. And so when given a choice, upper management will make the decision of having the latest and easiest for making money making.
Yeah. Legacy software.
Sets of priorities.
I think
And
that's
then-
quite tricky. Like
Yeah,
it.
and then if you're in a production environment or utility environment, you are in an environment where you cannot. It has to be 100%
Yeah.
uptime.
Yeah,
You
yeah.
don't have change control. You don't have scheduled down windows where
Yeah.
you can make updates.
Yeah.
Or automatic updates are not an option. They're manually applied.
Okay.
So you will have obstacles within
Yeah.
your business environment, depending on what your industry is or what your
Understood.
environment is, and the support from the higher ups.
Yeah. I did not think of this scenario, but yeah. No idea. So, do you have any other questions?
No more questions.
Sorry.
Oh, the word you were looking for was rubber ducky.
Yeah.
Yeah, so you weren't talking about ACE?
Yeah. This one.
Yes, ACE. So the word you're looking for is rubber ducky, where you see someone come into the action movie and they take a USB and they plug it in
Yeah.
to the computer and like they start uploading,
Yeah.
and yeah, that's it's the rubber ducky.
Good.
So the thing you automatically want to do in your company is harden all the computers. So software developers can't create code on their own computers. They have to do it in a secured environment, either in the data center or the cloud, and that way you have a more secure SDLC.
Okay. Yeah, makes sense. But Red Hat being Red Hat, I could plug anything into this and download anything, upload anything.
Well, that's where we have a hardened Linux,
Yeah.
where you just say when you
Disable
roll
tools.
out a gold image, you say, okay, this software is no longer available to you because we've removed it from your when we rolled it out to you.
I think that would make sense for production systems very much, but I don't know company policies to change. Like,
Well, that's where you have to have a company policy to say,
Yeah.
okay, depending on your role, you will have
Allowed to
these features,
Yeah.
on your computer, and so depending on where you are, it's called least privilege and zero trust. Yeah. So, all right. Anybody? The only one?
Any more questions in the room? Okay, well, thank you,
All good.
Suyash.
Yeah.